Connectors. Connectors with special shaped bodies or pin socket arrangements are called keyed connectors. So this is a typical connector for connecting up a 2-meter or dual band radio. And it's typically used because you can't hook it up the wrong way. You can't connect your radio backwards with, positive to negative. So these adapters allow different types of connectors to be connected to the same or different connectors. You're always going to need some of these. You got a barrel connector here from one PL259 to another.
Every ham has a baggie full of this stuff.
Yeah, oh yeah.
Well, I've got 50 baggies full of it.
You want the least amount of connector.
Yeah, so what, you think we could just use as many as you want, but with every time you put a connector in your transmission line, you're taking a little bit of a hit. Maybe not quite half a dB. So that's a typical power connector, and a standard plug to a power input jack. Low current, commonly used on handheld transceivers and station accessories. So you may have a handheld and you want to charge it, and you have the capability to connect your charger directly to the unit without having to take the battery out. So your HF rigs may use something like this called a Molex connector, anywhere from 4 to 6 connections on the back. I see variations of this. I don't see the exact Molex connector, but there are variations out there. So many HF transceivers use the 6-pin connector. Pins parallel can be used to increase current capacity. So what would happen if you put too much current through a couple of those pins?
That's why they have the fuse.
You can melt the connector. So power connectors, terminal strips, it's just an easy way to connect a number of different things together. Audio plugs, plugs and phone jacks. They use these for headphones, Morse code keys, control signals, come in standard 1/4-inch size. Aircraft is .206. And miniatures 1/8. Most of the stuff now is 1/8, but pretty much your headphone jack is a standard 1/4-inch. Audio and control connectors, RCA phono plugs. The phono plug has this funny little positive connection here, and then the other connection is in the barrel. So it's generally a shielded 2-connector plug. Good for audio, low-level RF, and control signals. In the back of the HF transceiver now, there's often a couple of these jacks, either for an amplifier or a jack
Key circuit or signals of some variety.
going to digital. Yeah. There's a DIN connector. This is typically between the HF rig and a computer. Be careful of these little guys. So notice there's a notch at the bottom here. Well, that notch, if this is the plug, there's a little, what would you call it?
Alignment.
That lines up with this notch, and that's how you can plug it all the way in. But if it's not lined up,
or
you can bend these pins.
Or you got an extra pin.
Yeah.
Make sure you got the right number of pins in the right place.
And depending on the plug, some of these pins are nice and robust and don't bend easily. Others are just like a wire. There's not much to it. And boy, you get that.
The next slide shows the mini DIMMs.
So you have to disconnect that often, or?
No, thankfully, not very often.
Okay.
But you do need to be aware of where these things go.
This will be the programming cable between your VHF rig and the computer when you're setting up all the frequencies in it. So the DIN label comes from the Deutsche Institut für Normen. It's just a German national standard used for audio and control signals. And there's a mini DIN. I guess these are the ones that are most likely to bend.
These are the ones that are more awkward, yes.
Yeah, they're
And they have different keying methods as well.
And then your RF connectors. Okay,
Keep
HF
going.
and VHF. A PL259
So,
is this guy up here. Socket is an SL239. And really the nomenclature is just so you could order one of these or know what somebody's talking about when they're putting a cable together. They're commonly used at HF and VHF frequencies, up to 1.5 kilowatts. They're not weather resistant, so you need to wrap them in some weatherproofing material.
you can buy these on Amazon, you can get the adapters through Ham Radio.
And you can get cheap one of these, you know, you can get these for $10 for 10.
Yeah. But,
And you'll get what you pay for. Ordinarily, they cost maybe $3 a piece. So this is an N connector, most suitable about 400 megahertz. So if you've got microwave, higher frequency stuff going on that is above 400 megahertz, you know, if you're doing 440 and up, you'd want to go to N connectors. They're good up to 10 gigahertz.
and it's yellow, so.
Yeah, they're weather and moisture resistant. Up to 1.5 kilowatts, they're constant impedance, 50 or 75 ohm versions are available. So why would you want to use the UHF connector instead of an N? These are more difficult to put on a piece of coax, and they're more expensive, but that's basically it. And this is a BNC connector. It's a bayonet connection. Typically up to 4 gigahertz upper frequency limit, 50 ohm. They're fairly easy to put on the coax. So an SMA connector is even smaller. This is the general connector that's used for your HT. Mine came with an SMA. I used an SMA to BNC adapter. Once that's on, now I can take the antenna off and on with one twist. So the SMAs are actually really efficient. They're very low loss, good up to 18 gigahertz, low power, and data connectors. This is the typical connector you see on the back of your computer. DB25 is one type, serial ports is another, parallel printer ports, a DB9, incorrectly known as a DB9. I've always called it a DB9.
Really?
Yeah. And your serial COM ports. So you got USB connectors. Yay, USB connectors. There's a bunch of those too. Got miniature, micro, and high speed. So that's pretty much replacing the old RS-232 connector.
Yeah, that one on the far right, and in a regular what you're used to, is the new kind of standard for connecting your new radio to your computer for digital modes and logging, and it pulls the data. So when I'm doing a talk test and I change frequencies, it sends that frequency through that to my logging software, so it tells me what frequency I'm on and the upper or lower sideband and everything else.
So we got some questions. In what configuration are the individual cells in a solar panel connected together?
Alpha.
Alpha, that's right. What is the approximate open circuit voltage of a fully illuminated silicon photovoltaic cell? That's right. We only get half a volt out. Why should a series diode be connected between a solar panel and a storage battery that's being charged by the panel? To prevent discharge of the battery through the panel during times of low or no illumination. That's correct. What precaution should be taken when connecting a solar panel to a lithium iron phosphate battery? Delta. Must be on a charge controller.
The charge controller for lithium batteries.
It's limiting what goes into the battery so it doesn't boil off the electrolyte or overcharge it. What's the minimum allowable discharge voltage for a maximum life of a standard 12-volt lead acid battery?
But the real world
But
is?
the real world,
Yes.
Yeah.
12 volts.
And your radio probably will not operate at 10.5 anymore.
No, it's probably good down to about
Shut
11
down.
and a half.
Yeah, it's gonna shut down.
Yep,
It's gonna work just fine until you push that button. And
yep.
it's gonna go, voltage drop.
What's the advantage of batteries with low internal resistance? High discharge current. And that's one of the reasons we like the lithium ion, because it can take a lot of current. Which of the following battery chemistries is rechargeable? That is correct. Which of the following battery chemistries is not rechargeable? Carbon zinc. That's your D set, your C set, your 9-volt battery, the little battery. Is there any reason for us to use non-rechargeable batteries in like an HT?
Yes.
So you might be in a situation when the power goes down that, okay, you've got a spare rechargeable battery for your HT. What happens when that goes dead? It'd be nice to have a battery pack that, you've got all these 1.5 volt AA cells. It'd be nice to be able to stick those in there and keep on going.
The other times you're gonna need that is if you are involved in emergency comm and you get asked to go help out in some area that needs help. They're not gonna have any idea what everybody's radios that they're bringing are gonna be. They're gonna bring a box, AA batteries. And then if you have a AA battery pack, you can use the AA's on your radio. And if you have a valve fan with AA battery pack, you better have a dummy load, because lithium batteries are 1.2 rechargeable, generally all rechargeable batteries are 1.2 volts apiece on a 1.5 volt AA battery.
Right.
You add up 6 times 1.2 and you are within the voltage
You're
spec
down a volt.
of the valve fan. But if you put in 6 1.5 volt AA carbon zinc batteries, you're above the voltage it'll allow you to transmit with until the batteries die down, and at that point they're almost dead because they drop off, remember? So you put that dummy load. So if you're planning to do that kind of work, have a dummy battery and have a AA battery pack.
Which of the following connectors would be a good choice for serial data port?
For
Bravo?
a serial data port,
Serial data port. Delta. Type N is for UHF. PL259 is HF and VHF. And SMA, they use that in your HT. Which of these connector types is commonly used for RF service at frequencies up to 150 megahertz? RF connector.
Charlie.
So an octal is not an RF connector, an RJ11 is not an
RG11 is a telephone connector.
that's a telephone connector. A DB25 is digital, it's got to be C.
PL259, burn that in your brain, because that's what's on the end of almost all the coax.
Which of these connector types is commonly used for low frequency or DC signal connections to a transceiver? Well, we know the PL259 is for RF. We know the BNC is also for RF. And we know the type N connector is for RF, but UHF frequencies.
Signals
It's gotta be C.
are RCA phones.
What is an SMA connector?
Bravo.
A small threaded connector suitable for signals up to several gigahertz. Right. Which of the following describes a type N connector?
Alpha.
Alpha it is, because it's moisture resistant and good up to 10 gigahertz. What is the function of a power supply bleeder resistor?
Bravo.
It discharges the filter capacitors when power is removed?
Yes.
Yes. Which of the following components are used in a power supply filter network?
Charlie.
Bravo. All choices are right. Diodes, transformers, capacitors, inductors, they're all used.
And when you say two of them is, it's all over.
What is the peak inverse voltage across the rectifiers in a full wave bridge power supply? The peak inverse voltage across the rectifiers in a full wave bridge power supply. 1/4 the normal output, half the normal output, double the normal peak output, or equal to the normal peak output.
Speak up.
Delta.
Tell them all. Own it.
Delta. They're trying to confuse you.
Yeah, I was just gonna say, they're trying to confuse you with a lot of extra words. Yep.
Yeah. What portion of the AC cycle is converted to DC by a half-wave rectifier?
Everybody's gonna get this right, correct?
Yes.
So the whole cycle is 360 degrees. There you go. What portion of the AC cycle is converted to DC by a full-wave rectifier?
Delta.
Yeah, I got it. Which type of rectifier circuit uses two diodes and a center tapped transformer?
Alpha.
Why? It is alpha, full wave. But, yeah, a half wave only uses one diode.
Yep.
It's got half the,
Oh, what about a full wave bridge?
Full wave bridge uses 4 diodes,
Oh,
but it doesn't use a center tap transformer.
So they're trying to cheat, they're trying to trick you again, aren't they? They got full wave up there twice.
Don't mess with it.
what is characteristic of a half wave rectifier in a power supply?
Alpha.
Alpha? Yes, only one diode is required. What's the output waveform of an unfiltered full wave rectifier connected to a resistive load?
Alpha. Delta.
Wow, we got Alpha, Bravo, and Delta. Okay,
One of us is right.
so.
It is alpha. A series of DC pulses at twice the frequency of the AC input. Which of the following is characteristic of a switch mode power supply as compared to a linear power supply?
Charlie.
I hear a Charlie,
Bravo.
I hear a Bravo.
It's actually more circuit components by the
You
way.
got more circuit components than switching. It is Charlie. High frequency operation allows the use of smaller components. And smaller components generally cheaper and lighter. Analog and digital meters. So an analog meter is one that's got a pointer. It's got a needle, swings back and forth.
Awesome devices to have, by the way.
Yep. A volt DVM, a VTD VM, a volt ohm meter is a volt. Accuracy expressed in percent of full scale. If accuracy is 2% of full scale on a 100 milliamp scale, then the accuracy is plus or minus 2 milliamps.
So if you're only reading 5 milliamps down the low end of that scale, plus or minus 2, well, you could be all over the board and not know it.
So resolution, the precision is expressed in digits, typically 3 digits, 0.00 to 1.999. Do not confuse resolution with accuracy. So, multimeters, you've got analog like this. This is an old style, that's a Simpson. The Archibald movement, rotating coil suspended between permanent magnets. When the current flows to the coil rotates, moving the needle across the scale. Coil impedance affects accuracy.
That used to be the standard,
For many, many
Oh, yeah.
years.
Yep.
and now it's cheap Chinese.
Sensitivity is expressed in ohms per volt. 20,000 ohms per volt is a very good analog meter.
Simpson built the very best analog test devices around.
So I have a couple of meters. I have a cheapie. It's not analog, not anymore, but I got one that I bought at a ham fest for $10. It's a little guy.
Yeah.
It's compact. It does what I need. I just throw it in my tool bag.
And if it
And
breaks,
it's
you
there all
don't
the
cry.
time. I don't have to worry about it. Then I've got a better one. It's a clamp meter. It's much more accurate. I paid $50 or something like $60 for it. I use that around the house. So it depends on how you're using it. You don't need a lot of accuracy or a lot of reliability even if what you're measuring is simple, kind of a gross, is there a circuit here or not? Do I have voltage or not? Is it really putting out 12 volts or not? If you're really digging into a piece of equipment to accurately measure voltage, you're going to use something else. This uses a vacuum tube amplifier to improve sensitivity.
Drop it once, and you know what I'm going to work.
Also, your cheaper meters, like the one I got for $10, they're going to have a limited display. If it's analog, it's going to have just a little tiny meter. If it's digital, you're not going to have as many digits. You get what you pay for, and it just needs to fit your needs. So digital meters have become the standard anymore. That's your go-to. The mode and the range might be switchable with a big rotary switch like this, or it might be auto-ranging, where you just hook it up and it automatically hits the right range.
And most auto rangers, you still have to select the function you need.
Yeah, you still have to select
And I
the
would-
function.
Be careful.
And I would suggest that if you're not familiar with them, don't buy an auto ranger, because you won't know what range you're on.
Yeah, you gotta watch that decimal point.
Yes, you got it. And the little letter beside it telling you if it's milliamps or amps.
Yeah.
And all that. So get one like this where you've got to select the range manually, and then you've got a better chance of it. But read the manual, because they don't have standardized symbols to tell you what AC and DC and all that is.
High input impedance reduces loading on a measured circuit.
This is incredibly important to us because when you put a meter on something, that meter becomes part of the circuit. So what you want to do is you want to cut that influence down as low as you can. Well, a high impedance meter does that. An analog meter does not.
Typically 10 mega ohms per volt or greater. That's that high impedance that we're looking for. Uses an internal microprocessor to perform measurement calculations. Analog meters have a faster response time though. So if you're looking for an intermittent in a circuit, maybe you've got a connection that's just off and on, off and on. Or, it's a piece of coax. And you're looking at the resistance in the circuit. And the resistance is going all over the place. If you're looking at a digital, those numbers up here are going to be scrambled. You're just going to look at all kinds of numbers and just go all over the place. Whereas on an analog, the analog is faster response time and is preferred to a digital meter when adjusting the circuit for maximum or minimum values. That's why we use an analog meter to adjust SWR. If you've got an intermittent, like a bad corrosion connection, you're going to see that needle bounce around.
And if you are using an antenna tuner, an analog meter works way better.
Oh yeah, way faster.
Yeah.
So for tuning an amplifier or an antenna tuner, you're going to use an analog. Digital meters, they're higher sensitivity, higher resolution. The oscilloscope, no, it doesn't oscillate on the bench, but it will display something that oscillates, which is the waveform. This will give you a frequency, and it'll give you an amplitude for that waveform. Dave, I will let you take it, because you know these way better than I do.
Anytime you want to look at a signal pattern of any variety, you need something in the neighborhood of an oscilloscope to see that pattern. This is what it's been designed to do. It does it really well. You can see attenuation with it, you can see level with it, you can see frequency with it, you can see offsets in digital versus analog. You can see offsets from a DC voltage applied to an AC signal. You can see so much with an oscilloscope that you can't see any other way. But it's an instrument that needs practice. Voltage measurements and complex waveforms is what it excels at. Voltage over time, signal over time, this is what it's designed to do. Different waveforms, you can see any type of waveform you want to see. Come on, machine. Here you go.
Yeah.
And oftentimes, most oscilloscopes have multiple channels. You can look at 2 signals at once with this little thing, or 4 signals at once. Multiple signals. Yeah, signal generators. It is exactly what it sounds like. It generates a signal. You can use it as a test device. This is its most common usage. In order to tune a receiver circuit, you need to be able to generate a signal that makes sense to that circuit. So you plug this thing in, and all of a sudden you're going to look to see how much you are influencing that circuit as you tune that thing. You want to look at the bandwidth that you're expecting. You want to look at the signal height that you're going to be plugging in there. You want to be able to reduce that signal and still have an intelligible output at the end. So a signal generator is the only tool that will actually get you there. A service monitor contains multiple instruments within the monitor. You can generate multiple different kinds of signals. You can see multiple different outputs. Service monitor is exactly the way to go if you're going to be doing FM multi-band equipment. It does a really good job. Unfortunately, that thing right there, that hertz that you're seeing right there, that thing's about $1,600. Service monitors require periodic calibration. So if you look at a service monitor and it's looking really good, and it's got a date on it that says due for calibration 1979,
The value just went down, I say?
yeah, you might want to second guess that one. You know? Okay, this brings up dummy loads. A dummy load is not an individual. In order to be able to transmit an output without putting a signal on the air, you use a dummy load. The idea behind the dummy load is you can do all the transmission you need to tune your radio for the best frequency output, for the best modulation output, all of the parameters that you want to see into a dummy load, and not influence your neighbor next door. Non-inductive resistor, and a heat sink. Why non-inductive?
It's a coil transmitter.
You betcha. It will influence what you're doing. Oh, this little dude right here. This is really good. Bruce is going to show you his. I didn't bring mine.
I'm gonna actually let you put your fingers on it.
Yeah. There are several manufacturers that make antenna analyzers, impedance and resonance measurement. An analyzer does exactly what it sounds like. Okay, this allows you to connect up a feed line or an antenna and actually read what the values are for that particular tool that you're looking at. If you want to look at your antenna and look at the impedance of that antenna over a specific frequency range, you can set it up to do that. If you want to look at your SWR, you can set it up to do that. If you want to look at a piece of coax cable, one end to the other, you put a dummy load out there, and you look at that wire, and there should be a constant impedance throughout the entire spectrum, et cetera, et cetera, et cetera. There's a lot of special things that you can do with an antenna analyzer.
Generally isn't a problem.
Right. The limiting factor on this is it is susceptible to strong signals. I set mine on the table, and if I touch the knob, it won't influence it. But if I touch the case,
Yeah, well, the knob's insulated,
yeah.
but you touch the metal case, and the values change.
So this is the test data that you need to memorize. You can connect it to the feed line, or your antenna, or the feed line and antenna combination. Field strength. Field strength is a really cool tool that's not used much anymore. Now, the problem with a field strength meter, and we're going to get to that here very shortly. Yes, it will measure field strength. That's its job, okay? But without it being calibrated and at a specific distance, you don't have a clue what you're seeing.
They are good for comparison.
Yes.
If you
comparison.
want to see whether or not the antenna is functioning the way it should, and you're comparing it against a known antenna, it's great for that, that's why.
And the key is that a field strength meter is measuring just exactly that. It's measuring an RF field. I've been using a bird watt meter just like that one since 1971. They just don't change. They're worth their weight in gold.
This is another one that you buy at a swap meet. And if you buy it in the last few hours of the swap meet, you get a really good deal.
So yes, the bird meter is this industrial standard that we all turn to. It does not measure SWR. You have to calculate SWR. It measures forward power, it measures reflected power. By knowing those two numbers, you can tell what your SWR will be. Questions, and this is it for the day, once we get done with the questions. What item of test equipment contains horizontal and vertical channel amplifiers? Anybody got a conclusion on this one? Vertical and horizontal amplifiers.
Delta.
That would be delta. Which of the following is an advantage of the oscilloscope versus a digital watt or digital voltmeter? Delta. Complex waveform is where an oscilloscope excels. Which of the following is the best instrument to use when checking the keying waveform of a CW transmitter?
It's on forward, it may not answer.
Say it again, sir. Anytime you want to see a waveform, use an oscilloscope. What signal source is connected to the vertical input of an oscilloscope when checking an RF envelope pattern on a transmitted signal? We're talking about the vertical input of an oscilloscope.
Delta.
Right on target.
Test probe.
Yeah. Whoops.
Bravo.
Come on.
We all win.
Why do voltmeters have high input impedance? Bravo. We talked about this kind of extensively.
I don't remember that.
Remember what I said? Every time you hook up a voltmeter on something, it becomes part of the circuit. It's loading that circuit.
High input impedance is to?
There it goes.
That's kind of a trick question.
Yeah.
It is.
That one is
They're saying number C, it improves the resolution of the readings. Resolution is not accuracy.
No, not at all. What's the advantage of a digital multimeter as compared to an analog multimeter?
Charlie. Delta.
Charlie.
Double hit there, but yes, you have the right answer.
Yeah.
But is an analog multimeter preferred to a digital multimeter? I heard a delta back there.
Delta.
Which of the following can be determined with a directional wattmeter?
Alpha.
Any conflict there? Alpha is correct. Which of the following must be connected to an antenna analyzer when it is being used for SWR measurements?
Charlie.
Why is that? It's because the antenna and the feed line are a single system. What effect can strong signals from nearby transmitters have on an antenna analyzer?
Bravo.
I would say delta.
Delta.
Ah, okay.
You're right.
You did good. You did good.
Lots.
You guys can read as well as I can. I'm not going to read.
Charlie.
I heard a Charlie. Anything else? Different wording for a question we've already had.
Yep.
Delta.
Perfect answer.